Hi, guys. Okay, so let's look at the exercise problems from chapter 15 on equilibrium. This is from the book Libre text, Introductory Chemistry book by Dro. Okay, so here's the first question, 15.6.1. Here we are being asked to write the equilibrium expression for two reactions they have given us. We need to write the equilibrium expression K and Kp. Okay, so first of all, keep this in mind that when we write the equilibrium expressions for the solids, liquids, or for AQ, it is always equal to, considered as 1. Okay, so next thing is that the general value is Keq is equal to the concentration of the products. So product A multiplied by product B, raised to the power their coefficients. So here this is going to be X over the concentration of the reactants raised to the power their exponent. So this is one example. Next, Kp represents the partial pressure. So the partial pressure of whatever the reactants are, that partial pressure of reactant A and the partial pressure of reactant B are going to be in the bottom, in the denominator, and the partial pressures of whatever the gases are. Say, let's say this is A raised to the power X. So the partial pressure of the, let me put this here, the partial pressure of the products, and that's raised to the power their exponents over the partial pressure of the reactants, and then that also raised to the power their exponents. Okay, so here let's look at this for calcium carbonate. So because calcium carbonate have solid, so this is going to be 1. Calcium carbonate, sorry, this should be calcium carbonate. Should be calcium oxide, not this thing. So here, calcium oxide as a solid. So this is also going to be 1. So we will just write the answer. In other words, is K is equal to the, for CO2, the concentration of CO2. We only write for gases, CO2. And because CO2, the exponent is, is just 1. So we won't write it. Okay. So this is one answer. Next is in terms of Kp. That is the partial pressure. How are we going to write it? Kp is the partial pressure P of the CO2 gas. And since it's all 1, since all this is raised to the power 1, so this just becomes the partial pressure of CO2. And that is the value of Kp. Okay, so this is one thing. Next, let's look at the next example here. Once again, we have solid. So for the solid, it's just 1. And the rest are all gases. So the value of Keq or K is equal to the concentration of the product. So the concentration of CO2 raised to the power 6 multiplied by the concentration of water, H2O, raised to the power 6 over the concentration of the reactants, which is C6H12O6. Okay. Oh, sorry, wait a minute. That is a solid, so we won't write that. Sorry about that. Over the concentration of oxygen raised to the power 6. Okay, so this is the Keq. Okay, so because for the solid, it is always 1, so we don't write it. Okay, next is this solid, that solid. Okay, next is the Kp value. Kp relates to the partial pressure. So here, what will we write? The partial pressure of CO2 raised to the power 6, right? Partial pressure raised to the power 6 multiplied by of CO2, multiply that of water vapors, partial pressure of water raised to the power 6 over the partial pressure of oxygen, raised to the power 6. Okay, so whatever values these are, the values of either the partial pressures will be given to you, or the values of the concentration and molarity will be given to you. So when these are given, so remember, partial pressure, let me write this here, partial pressure P is equal to partial pressure, and this partial pressure is of the gases, and the value is generally atm or millimeters of mercury. But for the one that is in square bracket, this is concentration, and the concentration is going to be in molarity. Concentration, the value is in molarity. Molarity. Okay. All right. So some of these, this chapter was a very small chapter, and this was just one thing they gave you. But from my side, I'm giving you some more problems. Okay. So here you are given the concentration. You're given a reaction: carbon dioxide reacting with water, giving you carbon monoxide, and giving you carbon monoxide and water. So here you see all of them are gases. So first question is, find the concentration of carbon monoxide when you are given the molarity of CO2, you're given the molarity, the concentration of hydrogen, you're given for water, find for the molarity or the concentration of carbon monoxide. The value of Kc is also given. So always write the formula. So the formula Kc is equal to, Keq. So it means the same. This is constant. So it means the same. So Keq is equal to, let's write down the equation first of all, concentration of carbon monoxide multiplied by the concentration of water raised to the power, over the concentration of CO2 multiplied by the concentration of hydrogen. Okay, so here you're going to write down, just put in the numbers now. So first we will write down Keq. Keq is 0.11, and that is equal to the concentration of CO, this is what we are finding, multiplied by the concentration of water, which is 0.50 m. Okay, that's the molarity, over the concentration of CO2, which is 0.25. Okay, multiply by the concentration of hydrogen, which is 0.80. Okay, so here what do you get? You get, going to, let's do the math, 0.11. Let's multiply this. So here we have 0.25 times 0.80. And that gives you 0.2. Okay, so here, concentration of CO, 0.50 over 0.20. Okay, so when you multiply these two, we get this. And now just do this. So times 0.20, divide that by 0.50 is equal to the concentration of carbon monoxide. Okay, so 0.2 times 0.11, divide that by 0.50, and you get 0.044 m, molarity m. So that is the answer. Okay, so this is the answer. So this type of question can be on the exam, where you will be given the concentrations, or you will be given the Kc value and find for the unknown. Okay, so that's one piece. Next is, let's look at another one. Here you're given another reaction. Ammonia at equilibrium is giving hydrogen and nitrogen. So all of them are gases. So fine. So first write down the Keq is equal to, for the hydrogen, so the concentration of hydrogen, H2 raised to the power 3, multiplied by the concentration of nitrogen, over the concentration of NH3 raised to the power 2. So remember that this is the coefficient, this coefficient is here, and there's no coefficient, so there's nothing here. Okay, so next is, we need to find the value of Kc or Keq. It means the same. Keq, what is that? Equilibrium constant. So just plug in the numbers here. Hydrogen is, so 0.60 raised to the power 3, multiply by, for nitrogen, 0.20. Okay, and all of this is over NH3. NH3 is 0.040 raised to the power 2. Okay, 0.0 ammonia, 0.040 raised to the power 2. So here you have 0.60 times 0.60 times 0.60. So that's thing. And then this number is equal to 0.216. So let me just do it just for the sake of, so this becomes 0.216. And this is being multiplied by 0.20. Okay, over, let's do the bottom one also, 0.040 times 0.040. And here you get 0.0016. Okay, so 0.216 times 0.20 is equal to Keq is equal to 0.0432. Okay, divide that by 0.0016, and that gives you 27. Divide that by 0.0016, and this is equal to 27. Okay, now another question can be asked. This means that the value of Keq, the equilibrium constant, is more than 1, right? So what does this mean? This means that the concentration of the products is more than the concentration of the reactants. This also means that the reaction is moving forward in the forward direction. That means moving from left to left to right. Okay. All right, so that's one piece. Next is the Le Chatelier's principle. So there is always going to be one question from the Le Chatelier's principle on the exam. Okay, now here, what do you see? You see you are given methanol, that is CH3OH, reacting with oxygen, basically a combustion reaction, and that's giving you carbon dioxide, water, and you are generating heat. So this number means heat. So that means this is an exothermic reaction. This is an exothermic reaction. The heat is being liberated. In exothermic reaction, the heat is being given. Heat is given off. Or you can also see that heat is a part of the product. Okay, now what happens when you apply these stressors, when you apply these change, what is the direction of the equilibrium? Describe, should be DIS, describe, so you get it, describe the effect in equilibrium to the following. Okay, or in other words, what direction does the equilibrium move? What is the effect in equilibrium to the following changes? So if you add more CO2, now every time, wherever you apply a stress or a change, you will see the response on the opposite side. So if you apply more of the CO2 is add more of the CO2, the reaction is going to move backward. So the change is always in the opposite side. So the reaction moves backward. And when the reaction moves backward, that means the concentration of the reactants is more than the concentration of the products. Okay, so that's one piece. Next is if you add more of the oxygen, now you're bringing in more of the oxygen. So if you're adding more, so you're adding, so lots of oxygen will quickly add with methanol, and what are you going to get? The reaction is going to move forward. And in that case, the concentration of the products is going to increase. So the concentration of the products is more than the concentration of the reactants. Now, increase the volume of the container. Remember, when the volume increases, the reaction moves in the direction where there are more moles. If the volume decreases, then the reaction will move in the direction where there are less moles. So let's see where are more moles. So this is 3 plus 2. So this makes it 5 moles here, a total of 5 moles. And here you have 2 plus 4, and that is equal to 6 moles. So which side is more moles? Towards the towards the product side. So in this case, the reaction will move, reaction moves forward. And when reaction moves forward, that means there are more products. The concentration of the products is more than the concentration of the reactants. All right. Now, if you increase the temperature, now here's interesting piece. You are increasing the temperature, means that you are adding more heat, right? When you add more heat on this side, the reaction is going to move backward. So here, reaction moves backward. BWD is backward. So when that means there are more reactants than the products. Okay, now if you add a catalyst, what happens? No change. Catalyst has no change on the equilibrium. Okay, so I highly recommend that you also please look at the problems that are discussed in the lecture. So please look at the problems and, examples, some more examples discussed in lecture for your, because this book has very limited question answers. Okay, so get that from the practice. Okay, so that finishes this. Thank you for watching.